Hello, welcome to another micro tutoring session from Prep Plus. Prep Plus micro tutoring sessions unlock the secrets to common exam and homework problems in math and physics. Today's problem will be a calculus problem in differentiation. So let's just get right to it. Suppose you have an exam problem to calculate the following derivative. Calculate the derivative with respect to x of the function beta, which is just some constant, raised to the x power. How do you do that? This is the problem on the exam. So we look at this and we say, the conventional rules for calculating derivatives of functions to a power of, say, x to a power don't really apply. So, like calculating the derivative of x squared is 2 times x to the 1 power. That's not what this looks like. So now, so we have to really kind of apply a trick in order to solve this problem. So we know, so let's do an aside first to just kind of convince ourselves of a solution strategy. So let's take an aside, and I want you to think, when you see an exponent like this, beta raised to the x power, think exponent. Let's see. From the rules of logarithms and exponents, let's see, beta to the x, the logarithm of that is x raised, x times log of beta. That's just from the rules of logarithms. And this logarithm can be with respect to any base. It can be log base 10, log base 2, log base e. It doesn't matter. Whatever base you want, the rules of logarithms always apply. So this means that I can write beta to the x. I'm going to work in base e. So that means beta to the x equals e raised to the power of log beta to the x, okay, which is what we just wrote down, e raised to the power x times log of beta. So all we've done so far is an aside to figure out a solution strategy for this problem. And we found that beta to the x, which is the function that whose derivative we're interested in calculating, beta to the x can be written as e raised to the power x times log of beta. Okay, so that's the end of the aside. Let's go ahead and do the problem. So that's the end of the aside. Let's go ahead and do the problem. So d by dx of beta to the x is d by dx, well, we just rewrote beta to the x down here, e to the x times log of beta. All right, let's just keep going. This, well, we know from rules of calculating derivatives, d by dx of e raised to anything, well, first you just take that e raised to the power and then take the derivative of the power. So that is e raised to the power x log beta times the derivative with respect to x of this exponent, x times log of beta. Okay, so far, so calculating the derivative of beta to the x is this product, e raised to the power x log beta times the derivative of the quantity x times log beta. Okay? So this thing is just, we just apply the product rule for derivatives. No problem. So e to the x times log of beta times, first the derivative of x with respect to x times log beta plus x times the derivative of log beta with respect to x. So the derivative of x with respect to x is 1 times log beta plus x times the derivative of log beta with respect to x. Log beta, its derivative with respect to x is 0. There's no x in here, so it has no dependency on x, times 0. So this is e to the x times log beta times log beta. Almost there. This guy right here is beta to the x. To the x times log of beta. And that's our answer. So the problem that we were given was to calculate the derivative with respect to x of beta raised to the x power, and the answer is beta raised to the x power times logarithm of beta. That's it for today's micro tutoring session from Prep Plus. Prep Plus is your online solution for customized tutoring for high school and college math and physics. I'm Rodney Green, the president of Prep Plus, and I invite you to contact me to schedule a free consultation. Check out the website prepplusinc.com.